Hello, welcome to ANS Solver. This is the sixth question of the paper. So as you can see, the past mean, okay, which is basically your lambda, because you are following a Poisson distribution, is 1.1. So I can write this as lambda, okay. So some new machinery is introduced and they claim that the mean has increased, which is a rival claim. Now, what they do is they test this at 1% significance level. We need to show the critical region, basically the area of rejection or from where rejection starts is x more than equal to 5. Okay, so I can state my null hypothesis to be my lambda equals to 1.1 and I can state my alternative hypothesis to be my lambda which is more than 1.1. So now, because I need to say that rejection starts from here, I need to prove that x more than equal to 4 is not, or basically is not rejected. So I'll write it like this. Okay. So this is basically 1 minus the probability of x less than equal to 3. So I can write this as 1 minus the probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2 plus the probability of x equals to 3. Correct? So now, the formula is basically e raised to minus lambda into lambda raised to x over x factorial. Correct? So using this formula, I can write this basically as 1 minus e raised to minus 1.1 into e raised to plus e raised to minus 1.1 into 1.1 plus e raised to minus 1.1 into 1.1 raised to 2 over 2 factorial. Okay, plus e raised to minus 1.1 into 1.1 raised to 3 over 3 factorial. Correct? Now, rather than you writing this full thing on the Cal C for the summation, I can tell you a simpler method. What you can do is on the Cal C, okay, what you simply do is click on shift and then click on the log button, which looks something like this. Okay, when you do that, you'll get a summation sign with a box here, and a bracket. So what you basically do is you're calculating the summation basically from 0 to 3. So write 0 here, write 3 here. Now you can write this as e raised to minus 1.1 into 1.1 raised to x over x factorial. Correct? X will basically take all the values from 0 to 3 inclusive. Agreed? So when you write this, and to write an x, you can simply click on alpha and the closing bracket sign. When you do that, you get your answer basically as 0.974. Now you can do 1 minus that because of this, okay, which basically gives you your answer, okay, as 0.0257, and when you compare your significance level, which is 1%, 0.01, 0.0257 is more. That means this is not rejected. But now if you see the probability of x more than equal to 5, which is basically 1 minus the probability of x less than equal to 4. So to calculate this, you can maintain this equation, but what you can do is instead of 3 here, you can click on 4. Okay, so when you do that, just give me 1 second, even I'm doing it on the Cal C. Okay, it's a very good way of on the Cal C where you can know your answer. When you do that, you get your answer as 1 minus 0.9945. So you get your answer basically as 0.005435, which is less than 0.01. Hence, rejection starts from x more than equal to 5, because even x more than equal to 6, 7, 8, 9, 10 will all be rejected. So basically x more than equal to 5 is where the rejection starts and is your critical region. Later, they carry out a similar test, also at 1% significance level. Explain the meaning of a type 1 error in this context and state the probability of a type 1 error. So the type 1 error basically means when you reject your null hypothesis, but your null hypothesis is true. Basically the area of rejection or the probability of the critical region. Okay, now you know your critical region from part A is simply x more than equal to 5, and the probability we calculate for that is 0.00544. So I can write this as 0.00544, which is the final answer of part 2. Now, given that the mean is now 7, find the probability of a type 2 error. That basically means the probability of accepting the null hypothesis, but the null hypothesis is false. That's why it's an error. Okay, so what you basically need to do here is, if you know the area of rejection is this, then the area of acceptance is x less than equal to 4. Agreed? So we need to calculate this probability of, basically you need to calculate the probability of acceptance using this as your lambda. So this basically means p of x equals to 0 plus p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 plus the p of x equals to 4. Okay, so now what I can simply do is, I know the formula obviously, in part 1 also I said, it's e raised to minus lambda into lambda raised to x over x factorial. So now I can simply write this as e raised to minus 7 plus e raised to minus 7 into 7 plus e raised to minus 7 into 7 raised to 2 over 2 factorial plus e raised to minus 7 into 7 raised to 3 over 3 factorial plus e raised to minus 7 into 7 raised to 4 over 4 factorial. So now, basically because there's a lot to write on the calci, what you can simply do is, on the calci, you can click on shift, then click on log, which is written something like this. When you do that, you get a summation sign with a lower limit and an upper limit. Correct? So now what I can simply do is, if you see here, we are calculating the summation basically from 0 to 4. So I can simply write 0 here, I can write 4 here. And here I can simply write e raised to minus, I know my lambda is 7, into 7 raised to x over x factorial. X basically takes all the values from 0 to 4 inclusive. And to write an x, you can simply click on alpha, okay, and the closing button. Okay, so now when you type this on the calci, even I'm doing it, just give me 1 second. 0 to 4. So when you do that on the calci, you simply get 0.173. Agreed? Okay, so now what you need to do is, this is basically the probability of a type 2 error. Okay, because you're accepting your null hypothesis but with a new lambda value.